Good. Thank you. I have also said, yeah, got it. Now, I really like Java, and in the recent years, I even do more Java because of serverless, which is interesting. And so basically, I'm freelancer since 1997, started with Java in 1995, and rest is just working with Java. So this is my entire history. What may be interesting for you, there is a podcast also with Marcus. There are some courses, my blog is maybe interested as well. And the most interesting part is if there are any questions left, Airhacks TV, first Monday of the month, I'm answering our questions. And some people in the chat also participated in the show, so thank you. Okay, now, this is for Marcus. So I had a chat with Marcus, and Marcus told me a few years ago, I was not very positive about AWS Lambda. And I thought about this, what I said, but what I remember is it was the conference, JCon conference, I think in 2017. It's a large German conference, a really nice one. And what I did, I compared maybe Jakarta EAM with serverless. And what I'm pretty sure I showed like something like this. And what this is one example from Amazon. And this is a very specific Lambda, AWS Lambda. And this is the request stream handler Lambda. As you can see, this is input stream, output stream, and context. And so what I said, or what I say right now, or what I said before, I'm absolutely not interested in such a thing. So I think the days are over where I'm really would like, to parse input and output stream to achieve something. So this was the point back then. And is the point right now. And by the way, the other week, I think it was this week or 1 week earlier, I performed a code review, and there were a few Lambdas written in TypeScript. And my client asked me, review, please. Could you please review them? And what I saw is very similar to this, except what came in was an JSON HTTP event, and there was a huge switch statement. In case of get, do this, post, do this, put, do this, and so forth. So again, I'm not really interested in write such a low plumbing code. So this is now the clarifications back to Marcus, because he asked me, he challenged me. You said you don't like Lambdas back then. What's the deal with it? So still, I don't think such an approach is productive. And this really reminds me of my early servlet projects where we had to parse everything by hand. Okay, now let's back to how I started Java. So everything started with the Sun Java web server for me, and this looked actually very similar to this. So the first servlet, as you remember, there was a servlet, and there was an HTTP servlet, and in the servlet you had to parse, everything by yourself. And the HTTP servlet was a little bit smarter. And by the way, what I also found, so the history of Java. So this is my introduction. The one of the projects I was supposed actually to implement CGI bin backend server, which acts as a CMS system. And I had no idea about CGI. I only knew Java. So I waited until the Sun Java web server comes out, and I downloaded that. And what I found, this is the origin page of the Java web server. So I actually bought the CD. I still have it somewhere, the DVD or CD back then, no DVDs. And as you can see is plug and run, write once, run anywhere without having to port old CGI scripts. So this was actually the reason why I'm still doing Java on the backend. Exactly this site. This is from Internet Archives, by the way. And so what you see there, so we had servlets and one server, and this basically was. So you could put multiple servlets, but I don't know whether you remember, there was no XML deployment descriptors. There was like a strange way to package the server. There were just servlets, nothing else. This was the early Java, 1997. Okay, so what we got then were J2E application servers. So what we got the J2E application servers, and the J2E application servers had internally web containers and EJB containers. And there are lots of architects who believe that if we split this apart and we part to 2 layers and they are remote, it will scale better because of network magic or whatever, or Harry Potter patterns or whatever, right? So, and it didn't work that well, because if you split something apart, it doesn't have to scale better back then, at least. And what you had here, you had the wars here and EJB jars here, and they communicated usually via RMI or via OP or Corba. So this was a big deal back then. There were the J2E application servers, and they were very popular until 2004, I would say. So since Java 5 or Java 6, what happened is they found out actually it doesn't make any sense to split them. And there was some split, or still is internally, but what we got a WAR web archive, and we can put everything to the WAR and deploy it. So, and for me, it was actually serverless back then. Why? Because in most companies, we were actually not allowed to touch the server. So we packaged the WAR, we copied it somewhere over, and someone else deployed the WAR on the server. And I was only interested, and still I am interested in the business logic, and I'm absolutely not interested, in parsing HTTP stream or whatever. So, so this is actually always the same. This is maybe the reason why I really like serverless, because it is exactly the same concepts. So a little bit later, look like this. This is now Jakarta E application server. We say, okay, we try to make this spec a little bit simpler, and we don't like EJBs anymore. We can replicate the EJB logic with CDI, and what we don't like for sure to have remoting, so with serialization and RMI, and also not two-phase commit. So this is a bad idea. We don't do this anymore. So this is like Jakarta E, and then what happened? Then we got this. We got microprofile runtimes. Which microprofile runtimes do we have? We get Helidon, we have Quarkus, we have Cumulus, we have Piranha Cloud, and we have Payara Micro. And what they all do is there is no more separation between the application server and the business logic. So, or put it this way, what usually happens, they are still separated, but at build time, they are glued together. So this is what happens behind the scenes for optimization. Why? Back then, or back then, still application servers, how the separation is working. So you push the WAR, and the WAR is deployed at runtime. What deployment means, lots of reflection. Metadata is read, and from the metadata, they try to find out is it transactional or not, right? So this happens behind the scenes. Now, in microprofile, most of the microprofile runtimes were shipped on Docker. And Docker ran on Kubernetes, or why Kubernetes at all? So Kubernetes was never meant actually to use directly. It was always meant to be a foundation to build clouds, and something like OpenShift, for instance, is great. So you can use it on premise. It works perfectly. So without Kubernetes, Docker becomes hard. Why? Because of port conflicts, right? You cannot start multiple Docker containers in parallel, because you will have to care about the ports. Also, what Kubernetes does is very clever. It tries, per service, you get a single IP address, and there's etcd for configuration. But actually, we don't care about that. So, so what I would like to talk about today, and this is completely different, what I showed you at the beginning, is actually this. Exactly the same code which runs as Lambda. So this is for me a true progression. Why? I say in a second, because now I don't have to care about anything anymore. I'm just focused on my business logic, and someone else manages everything, right? And everything means, yeah, everything. Operating system, even Java. I don't care about Java anymore. I get the Java I know from Corretto 11, and it is patched by AWS for me, or Azure Functions, and it's patched by Microsoft for me, and they also are OpenJDK contributor. By the way, any questions so far? No, you can ask me questions, you can interrupt me, you should do this. I will show you code in a second. I won't write any code, I will more walk through the code. Okay, now, the cloud evolved as well. So this was the Java, and this is now what we do in a project. And sometimes you will see today with MicroStream two parts. One is this, and the other one, we don't even need microprofile anymore. We can ship plain Java SE, which listens to cloud events. I mean, it's not the cloud event standard, rather than to S3 events, to Kinesis event, SNS, and so forth. Okay, no questions. So this is a quick introduction to the entire thing, right? In the cloud. Now, what happened? I would say since 3 years, clouds became really popular. Why this? I would say not necessarily because we got more services. So at least in Europe, I can tell you why. what we got is the possibility that some technologies which are actually really important for enterprises. For instance, you take AWS, this is called Direct Connect and Private Link. What this enables you is to have basically hybrid clouds. This is extension of your intranet to the cloud. So, and this was actually the huge enabler, because large companies are now willing, to expand to the cloud. Before then, you will have, cloud was more about shipping, public services. In most my projects, all the services we are deploying are actually hidden, are not visible from outside. It is always the case on all the application servers, all the projects we did. Only a small percentage of our project was actually visible in the internet. Christoph said Aiden. Christoph, my name is Adam, A-D-A-M, but Aiden is even cooler, actually. I already thought to rename myself. So A-D-A-M, Adam, like the Eva, the first man in the history of humanity, I would say. Perfect. Thank you. But Aiden sounds nice. So, and this was a Direct Connect and Private Link, and on Azure we have Express Route, exactly the same technology. And what I told you with Java and J2E back then, there was we had exactly the same situation. Only a subset of all the projects were visible in the internet. So now, 3 years ago, there was explosion happened in the cloud. Everyone wanted to have a cloud. So, okay, why you would like to go to the cloud now? And there are a few reasons. One reason was capacity problems. So more and more applications, the data center was too small. So this was obvious. We have to expand to the cloud, right? Another two are not that obvious. One is security. Actually, in cloud, it's just a way easier to encrypt everything and make it more secure, and everything is certified. So whether it is more secure or not, no one actually cares in larger projects. What's more important thing is that we got the certification, the label, and it is politically correct to use the cloud. This is actually more important, because you cannot argue as a developer with managers in projects, right? So, but security is really true. You can encrypt whatever you like with your own key, usually. So we have, you have a security at rest and in transit. So this was the huge driver. The next one is DR, disaster recovery. With the clouds, it's fairly easy to have highly available applications, because usually what you get as a standard everywhere, you get a subnet, a VPC or a VNet with multiple subnets, and they are running usually in multiple AZs, availability zones, and availability zones are data centers. So you get, it is actually highly available out of the box. So I'm often in charge of architectures, and in a private data center, it is harder to achieve such a thing, because disaster recovery means what happens if this data center disappears? We need another one, which is close enough to have low latency, but far enough to withstand, catastrophe, right? So clouds are natural choice. So this were actually the main drivers in the cloud. And scalability, not really. I mean, most of the services in the cloud run on, a fraction of a CPU. So I would say a beefy application server can handle thousands of transactions per second. And usually the enterprise projects are not that, huge like Netflix or TikTok or whatever, that we need a huge scalability. So now about the cloud. So we have the situation right now. We have something on premise, and we would like, to extend to the cloud. What to do? So, and there is one idea, lift and shift. And I don't believe in it. You can do this. So what do you basically mean? Whatever you have on premise, you push to the cloud. So what happens then? Usually it becomes really expensive. And the next problem is the costs are not the problem. What the problem is, you cannot explain the management why it is that expensive. Because you can say, I need, Kubernetes with 4 or 5 worker nodes and whatever, and you will pay, 1,000 euros a month. This is like, the ground noise, and the management ask why, and we say, yeah, because we need Kubernetes, right? So this is the first problem. So you will see in a second, serverless is different. Why? Because you are not paying for the infrastructure, you're paying per invocation. So if we invoke a business function more often, we pay more. We invoke the function less often, we pay less, and the management can know from the invoice, we'll see what happens behind the scenes. So I don't have to explain myself why a use case is invoked several times a month. Okay, now what it means. This is a shared responsibility model from AWS. And this is the standard. It means I care about, the software, storage, compute, database, networking, and whatever. And the blue is I'm developer in charge of everything else. So what I don't like is the everything else, because we did it all the time on premise. In the cloud, I would like to see an improvement, a significant improvement. I don't like to care about operating systems anymore. So why we need cloud then? So, and by the way, there was a Sun cloud, not Sound, Sun Microsystems cloud back then. And the idea was actually that you are shipping, just the business logic to the cloud. This is what I would expect from a cloud. Or another great cloud software is called Payara Cloud. The Payara Cloud, what they do, the application server manages automatically Kubernetes for you, so you don't have to care about that, for instance, right? So this for me, not a huge improvement. Lift and shift means I shift everything to the cloud, and it's getting more expensive, but not necessarily better. Now, it changes with that. What this is the same with Lambda. This is actually the same picture. Here you can, again, here's the link. What with Lambda happens, the cloud, in this particular case, AWS, takes more responsibility, and I only care about the business logic. It's actually very similar to my Java EE idea that I don't like, to care about the plumbing. I only focus on the business logic. So this is what is more appealing to me. If we go to the cloud, from my perspective, there should be a significant added value. Just taking what we have and put into the cloud, we can do this, but there's I would say, no improvement. Okay, questions? No questions? Then, Marcus, what's wrong with you? You wanted to ask me a question at least. Now he's silent because he didn't saw the slides. These are new slides, so he was not prepared, for such interactive talk. Now, what this is later, this is AWS Lambda. And why I created the slide, because I always confuse Firecracker with Bottle Rocket. And in the last EGB talk, I was actually wrong because I forgot the names, and I say Lambda runs in a Docker container, which is not true. What Lambda runs is actually in a VM, on bare metal VM. This is the KVM, and Firecracker is very lightweight, isolated virtual machine. And the green part is what we care about. So the interesting part is I don't even care about Java. I get the Java from somewhere. I just say, I would like to have Java 11, and this is automatically patched for me. So it is really like, it should be, I'm just writing my Java code and I don't care about anything else. And I'm writing the Java code, which looks exactly the same, which code I wrote before, microprofile, JAX-ORS, and whatever. It's all the enterprise APIs, dependency injection of view classes. Okay, now a little bit further today, I will show you this use case. So we have this also from Amazon. So we have HTTP API gateway, which takes the HTTP request, and what it does, this HTTP request is converted to a JSON event, passed to Quarkus. Quarkus parses the HTTP event and invokes JAX-ORS. So the interesting part is, from the source code perspective, almost no difference to a usual microservice we wrote 10 years ago. You can reuse exactly the same code, but it is serverless. So this is the entry point. A little bit boring. Why boring? Because because it's not really asynchronous. We have the HTTP part. There are no events involved, but already you get paid per invocation. The first million invocations are free. Gigabyte seconds are free. I did the math several times. If it run it on ARM, it is 10% cheaper. Two invocations per second in Frankfurt cost about the entire month. 2 invocations per second, the entire month, 24/7 costs roughly $7 with 1 gigabyte of RAM memory. There are the costs. Okay, this is the first one. The more interested one is the second use case, also implemented with MicroStream. And this is the idea. We are no more interested in HTTP. We are interested in the cloud events. So what happens in the cloud? And this is the huge difference to on-premise. So, what it means is we have a lot of managed services in the cloud. So we have DynamoDB, we have Aurora DB, we have Kinesis, SNS, SQS, KMS, Code Pipeline, and so forth. And all these services, they are emitting events. And we can write Lambdas, which listen to the events, to the services, to listen to the events and do something with it. Back then, very similar to message-driven beans and JMS. So now we have Lambdas in the cloud. Very similar idea. The only difference is that now we are using JSON events, and back then everything was binary. Also, there was like a map message where internally there was like XML structure, but usually it was binary. So, and this is asynchronous event, and this is polling. So this is like the this Lambda runtime, not you. The Lambda runtime polls, Kinesis and Amazon DB and receives events. So I would say these two parts is like the future in the cloud. What means future? Let's assume you would like to upload an Excel sheet, which is common enterprise use case, and do something with it, scan it and process it. So you have two choices. You can use HTTP API gateway, write, multi-part upload with JAX-RS and read the stream and write it to a S3 bucket, or you can upload it directly to a S3 bucket and just listen to the event. Okay. Okay, Stephen from Tech Studio asked me, we are generally familiar with serverless. Perfect. Not to start flame wars, but many say don't use Java for serverless. This is also what I heard. They say JVM within a VM is too resource heavy compared to technologies such as Node.js. It is a start-stop latency. Waiting for your thoughts and ideas on optimization. No rush. Your question is my priority. So the funny thing is, Java works great as in serverless. Not great, but far better than, I don't like to start our flame wars, but then JavaScript, right? Why? And even it works that's great that in most projects we don't even use native image GraalVM. The reason being is if you would like to get more processing power, you can only do this buying more RAM. With 2 gigs of RAM, you get 1 virtual CPU. With 10 gigs of RAM, you get 4 CPUs. So if you have any logic to process, you will need some CPUs. I mean, without CPU, nothing will happen, right? So what it means is it is not cheaper to run, to write your function on assembler and run with 128 megs of RAM, because even assembler will need, CPU, and with 128 megs of RAM, you will get 1/10 of a CPU. So with Java, it runs the best with 1 CPU, which happens to be roughly 2 gigs of RAM. So this is the cheapest configuration you can get. And with 2 gigs of RAM, we don't even care. And 2 gigs of RAM is four times more than Quarkus even needs. I mean, with Quarkus, we can ship with 256 megs of RAM without any optimization, so no problem with it. Now, the cool story is with JVM, there is a cold start, takes 5 to 10 seconds, depends. But all subsequent calls get faster and faster. Why this? Because JVM optimizes and Lambda reuses the container, or how to call it, the runtime. So the longer the Lambda runs, the faster it gets up to the point. If I would use GraalVM native image, the cold start would be faster, but GraalVM optimizes currently less than the JVM because it does this. It happens only once, not the entire time. And if you would compare the performance with Python, Java, and Node.js, you will find that Java executes faster. Therefore, Java is cheaper. And it's cheaper because you all have paid invocation. So, Stephen, I hope it was a clear explanation. And the cool story is we can actually reuse the old J2E code without any rewrite. And all the microprofile apps are running as Lambda without any changes. And by the way, the Java Lambdas can be huge. In some project, there are several hundred classes without any impact. So because, I mean, the bandwidth, the disk bandwidth is great. And on Amazon, so it doesn't matter whether the image is 24 megs of RAM or 25 megs of RAM, and you can put a lot of Java classes into 1 megs of jar. Dependencies are bad, but we don't need any dependencies. Okay, Stephen, are you super happy? And we had the discussion all the time. So if you measure, you will find how well it actually behaves. Got me? no rush. So we discuss now the different, different Lambda options, and the future is, events, of course. But in Lambda, everything is event. Even the HTTP API gateway emits events. Okay, now what is the future? No activity, no charges. This means serverless. For me, if nothing happens, I don't like to pay anything. This is true serverless. And like databases like DynamoDB or partially AuroraDB, or it already happens, right? And Lambda is also perfect for it. So if there is a lot of traffic, I pay more, which makes sense. This is also more predictable and better for management, because we say, okay, every order costs you that much, and now the management can decide whether it is worth, to follow this route or not. But if I would run, an EC2 instance or Kubernetes all the time, I have to pay all the time, and no one knows what happens inside. Whether I have a real starts? Yes, go to my YouTube channel. There are lots of, you can watch how fast it is. And what I did, I shipped, a very simple Quarkus application, Hello World, and it executed, I think, in 1 to 2 milliseconds. So I mean, it cannot be even faster. It is fact, right? Yeah, watch the recent on my YouTube. There's not like significant, no scientific study. But this is what we did in projects. Java was faster than the competition. Oh, Mark Sales, thank you. So cost-driven architecture. This is requests are proportional to costs, and monthly cloud costs become the main non-functional requirement. So now this is from Amazon. This is like best practice in Python. We have post, put, delete, in several functions, and in Java, I wouldn't write such a thing. So the interesting part in Java is I would put everything in one resource, and if I do this, I'm more productive. And not even that, I can have multiple resources in a single Lambda function. And why that? The question is why not? So in Java, we are accustomed, to create larger services. So having even 20 endpoints in a function is not a problem. So recently I reviewed a project. They had 30 POMs, and roughly there were 30 functions, but the functions are larger. These were like micro-profile applications. And I also asked them, why you have 30 functions? We can even merge them further, because everything came with the same version. And if there's one team, one version, why to have 30 separate functions? You can have 30 separate functions, but shipped in one function.zip, for instance. No downside. So what it means is with Java, the next explanation from my point, Java is more productive than this. Because imagine if I have a standard JAX-ORS resource in Java, I would have to ship 5 functions, and in Java I can just ship 1. Okay, so what it means is fetch functions are still tiny. We have a JIT. It works better and better. The longer the function is running, desto faster it is. And in one project, there were problems with cold start. So you can buy, it's called provisioned concurrency. It's like a mean pool size of EJB. So they keeping the function warm. It costs a little bit, but there are no cold starts. But cold starts is usually not a problem. If your application is used in production, it's not a problem. If it's not used in production, you get 1 cold start an hour maybe. Okay, now MicroStream. You can say, okay, why I need MicroStream? And this is actually, I will show you in a code in a second. So this is a little bit harder to explain, but what happens in our function-driven development here, we get from outside JSON, and the JSON is deserialized into JSON-B objects. And the JSON-B objects can be fairly complex. And if you are using JSON, you have problems with circular dependencies, problems with generics. You cannot easily, or you can with JSON adapters, but problems with dates, with complex types. So the idea is what you can pick, and in this particular talk, I just using not even the MicroStream persistence, just the serializer. I can pick the MicroStream serializer and serialize all the objects. to a binary stream and save it, for instance, to S3. And I had a chat with MicroStream guys and said, okay, what we could also do, right? We have the binary stream from MicroStream. MicroStream could read the stream and create CSV, put it in another S3 bucket. And with S3 Select, I have a small database, very, very cheap one. And I don't have to care about the object serialization. So this is all about productivity and a little bit about performance, and performance is money. Yeah, time is money in the clouds. And MicroStream, what I like about MicroStream is very simple. It can be an object graph, which can be fairly complex. I don't have to implement serializable, and I can serialize the object graph. This is all I need. And it's a little bit faster than JSON, and I'm happy. So this is basically my use case of MicroStream. And another use case would be to use MicroStream as a persistence layer. But in this particular case, I'm just using a MicroStream as a very convenient serializer. And this is like a bridge between the synchronous and asynchronous Lambda. Okay, thank you. This were the slides. So I do a lot of slides, but I wanted to explain Marcus a little bit more. So this is the fault of Marcus. Okay, so first, set up Jakarta E projects, Jakarta E8, and of course, Jakarta E8, then my MicroStream, let's call it, because not micro. Everyone said, Java E is heavyweight. So let's call it MicroStream. Where I'm going to this, just give me 30 seconds. So structure, system test, this is the microservice, and how it looked like. We had JavaX at inject, JavaX RS, and this was my template and microprofile config property. This was a template I use in all commercial projects, Java 8, standard stock mix of Jakarta E and microprofile. And there was a system test. And the system test, there was an integration test, which used microprofile REST config and sometimes Java 11 HTTP client for system tests. So I used both. So this is how the code looked like. So another question from Christian. Yeah, the hot state, Christian, this is what I'm talking about. So the first call start is actually loading the runtime and everything, and then the function remains hot for a certain amount of time, and then it optimizes itself and it becomes faster and faster. And this is where we're saving money, exactly. Okay, so now this was the old one, MicroStream, and now look at the micro. And I got the idea from Rihad Fichtner, also joined here because of electric vehicles. And the idea is, create a small app which shows, vehicle charging. And so first, it is completely written in Java. So there are three parts. One comes more, and this is like self-provisioning runtimes. So why? So what you do in Java, we tied, the server, how to call it, a serverless app, business logic, and the infrastructure in one bundle. So, and this bundle is the CDK is in charge of deploying the app. But before we use the CDK part, I would like to show you the microservice. First, it's Quarkus, Java 11, can be Java 17. But right now it's Java 11. And what I use here Quarkyverse, Amazon Services, Amazon S3. So this is the AWS version 2 SDK of Quarkus. And why it's a little bit optimized from Quarkus. So what Quarkus does is it generates bytecode in advance, and it also drops stuff which is not used. And other than that, it is stock Quarkus app. The only thing is, this is the main difference. This Quarkus Amazon Lambda HTTP, if I run this, if I build this, it will create a function.zip and not function.jar. So this function is only suitable to ship it on to AWS Lambda. If I would deactivate this, it would create a jar. With that, it creates a zip. Does Lambda support Grpc? Of course, you can use whatever you like. I mean, yeah. I mean, how support this is just Java code. From the outside over HTTP API gateway, it supports WebSockets, and in this particular case is JAX or HTTP. And Lambda supports more. This particular Quarkus Lambda supports REST API gateway, HTTP API gateway, and ELB load balancer. Tested all three. And there's the MicroStream part. Okay. Now, if we take a look what happens behind the scenes, not AIX, of course not, charges, boundary, charges, resource. If you take a look at this, it is like it was, 20 years ago. It's a stock microprofile application, no difference. And I have here dependency injection at inject charger. So again, the same app, it doesn't run on Docker anymore. It runs on an AWS Lambda runtime. And the charger here, if you take a look at the charger, so it gets injected S3 storage, and it just, behind the scenes uses the S3 storage to fetch a vehicle, to get the charges for a vehicle and to the next charge. And this basically it. What happens behind the scenes in the S3 storage, it just saves, uses MicroStream serialize, which is, by the way, there are just two functions, serialize and deserialize. I had a chat with MicroStream people. It's like, okay, if you would like, to make MicroStream more popular, we need just 2-liner. Otherwise, I'm not interested in writing 10 lines of code, to serialize one class. So this is a fairly easy way of serialize an object, and the vehicle is just a vehicle. And the nice part is, you see, this is public. This is actually a JSON-B object, which I already had. It comes from HTTP API gateway, and this object would come, from Payara or Whitefly or whatever. I don't care. And I just pick the object, use MicroStream to serialize it somewhere. So I don't care what's inside. I just would like, to store it somewhere. Okay, now the interesting part is it uses S3. Why S3? Why not? I mean, we can just do it. It's the cheapest possibility. So just start with it. And this is pretty capable. So it even ships with SQL queries. It can be versioned. It can be replicated in the same region and across region. So you could even have a very simple cluster where you're writing to one S3 bucket and reading from the other in a complete different region. So I could write in Munich and Harpreet could read from Singapore, and it would work. So we get it for free, right? So this is the first part. So this is like CRUD with S3, so nothing special. A little bit more interesting is, on the other hand, we have the charges listener, and this is a true asynchronous Lambda. And in this particular case, I even didn't use Quarkus anymore because I don't have to. I could use Quarkus. It comes with great asynchronous support, but I don't have to. And you can see here, on charges arrival, this S3 event comes here. The question is, how they are wired. So why this Lambda knows what happens in the S3 bucket. And this is what I'll show you in a second, how this is wired. But point is, I get the standard S3 Amazon event, no external dependencies. This is the S3 event from Amazon. And I can just, read it and process it behind the scenes. Okay, now the question is how the entire thing is deployed. And this is deployed with Java as well. So no YAML, which is very good. So at least for me. So what this is called CDK, Cloud Development Kit. CDK comes from Amazon. And the cool story is it's basically a Maven project. So why it is cool? Because if you think about this, the entire cloud is the same for all projects on Earth, right? So there's always the same REST APIs. So what means is what we can do, we can write reusable pieces. Per projects, we create, a pipeline, a role, a VPC, a VPN connection. So everything is actually automated using Java objects. Now the cool story is, because this is Maven, we can actually push the Java objects to Nexus and make it reusable across teams. And we can even, have standard how VPC looks like in our company, how a microservice looks in a company, or how, MicroStream is configured with Lambdas, okay? Now, what happens here is the following. So there is a CDK app, and this is the MicroStream app. And this app starts with a stack, and the stack, the name of the stack is charges app. And we see here, I would like to have a bucket name with MicroStream 1. This is the name of the bucket. And so what happens here, I'm creating here an S3 bucket, and the S3 bucket is on another layer. This is the control layer, and this is the S3 bucket, again from Amazon. And I say, okay, the S3 bucket is created here and exposed via this get bucket. So what happens here? Charges app. I say, okay, I would like to have the S3 bucket. The S3 bucket is needed where? In the charges resource. So what is the charges resource? The charges resource is my function. This is my function, Lambda target function zip. This is what Quarkus created. As you can see, shared responsibility model, runtime, it is Java 11. The function handler is always the same, it's Quarkus. And we are running with 2 gigs of RAM because of the cheapest configuration. Actually, shortly before the show, I switched to 2 gigs. Usually, before that, it was 1 gig, but 2 gigs is usually the cheapest configuration. And there is, if you search, I think for Lambda power tuning in GitHub, you will find from AWS an open source project which exactly measures this. What is the cheapest configuration for you, or the fastest, or whatever. So concurrency is 2, means like this is like protection. There will be never more than 2 lambdas which are invoked concurrently. And the cool story is this here. Look at this map off is like config map. So what I can do with it, I can actually configure the lambda by passing configuration. So I'm passing the bucket arm and the bucket name, and my microprofile config application makes it injectable. So it's fully integrated with microprofile config. So also now here's the permission. The permissions are sometimes with IAM permissions. You can spend some time with CDK. You can say this bucket, I would like to make it readable and writable by this function. And what I also would like to have an HTTP API gateway integration. I could choose between HTTP API gateway. In some companies, we have to use REST API gateway because of private VPC integration, but you should prefer this one. And ALB also works great. This is Elastic Load Balancer. So Mark Salis is in the chat. So thank Mark for pointing to it works well with ELB as well. Okay, so this is the part of the function. And if the project is larger, so we have multiple such methods which create functions on the fly. So this is how it looks like here. So questions, Marcus? Do you have any questions regarding MicroStream? Everything clear? Marcus is the CTO or CEO, as is one of the CEOs for sure of MicroStream. So if I'm asking, about MicroStream, then okay. So what it means is, so the entire infrastructure's code is coded with Java. The code is Java. This can be stored in Maven and reused across projects. So this is actually the benefit. And we have a question here, Ben. Someone must have annotated a red line on the left side of the Zoom screen. I don't know. Red line? I don't see a red line. Sorry. Okay. And so I think we had, and now the charges listener. This is where what happens here. We are creating a function. This is a different one function. And what we have here, we have S3 read policy. So I'm allowing the function only to get the object. And what you see here, this is the integration point between the function and the bucket. This is where the function listens to the events of the S3 bucket. So and this basically it. So this is there are the 2 functions wired together as an app with CDK v2 and Maven, both shipped with Maven. Okay. What are the questions? So I heard something with Mike. No. Okay, then take a look. And by the way, if you're interested, the template is on my GitHub account, AWS Quarkus Lambda CDK plain. If you clone it and run it, you get a hello world example. I just extended this with the MicroStream. Okay. Now it is already deployed. So and this is the on my account. And this is the Lambda. There are two functions. One is called charges resource and the charges listener. And the charges resource here, it is configured. This is it runs on Intel. This is what I forgot to change. It should be actually ARM. It's a little bit faster, but it doesn't matter for Java. So you can pick. No reason to actually run it on Intel. It should be Graviton on ARM architecture. So this is forgot to change that. So this is the function, and as you can see, this function is integrated with API gateway. And if you go to the API gateway, this is actually the integration point. So what I could do is I could just try to, and try means really try, to run the system test. And let's see, this is the system test, by the way, forgot to show you this. The system test, it just invokes via HTTP client, this backend. In some project, I'm using MicroProfile REST client. It really depends on the requirements. And this is, I guess, is going to be a cold start. Yeah, this is a new URI. Let's see. It will take possibly 5 to 10 seconds. I don't know. This is the very first invocation, and the subsequent invocation are going to be faster. So this is the first one. This is the next one. You see, these are now the invocation of the performance of the entire MicroProfile application with dependency injection, MicroProfile config, entire microservice within a Lambda. Okay, now we can switch to a CloudWatch and see what happens behind the scenes. And watch CloudWatch and log groups. They are also created. Forgot to show you this. And there is a charges resource, and there is the stream, and this is 1251. And this is actually, you see, using bucket MicroStream 1. And we can maybe do this. This is visible. And the performance is 55 milliseconds with JSON retrieval and storage with MicroStream to S3 bucket synchronously. So asynchronously will be even faster. And all the objects have to be already in S3 service. Sorry, S3. And we have now MicroStream 1. And you see there are vehicles stored. There are 232 bytes with MicroStream. So this is a little bit boring use case, the first one, because what I'm just doing, I'm picking the objects, manipulating a little bit, and storing them as a stream in S3. But the next function can just pick, regardless how complex the graph is. This is like temporary store. I could also send it via SQS or whatever. And what then can happen, I get the objects back and then can process them and, for instance, convert them to JSON again and write them to Kinesis stream or S3 or whatever. So this was the basic use case, and step by step, walk through the code. What's interesting is the entire CDK is visible as a stack. So this is actually a huge benefit of CloudFormation or CDK. If you go to stacks, so you will see there is one charged stack. And if you go inside, you see actually what happened behind the scenes, which resources were created. And I can go here and delete the entire thing, for instance, right? So it's really convenient. So we have, I think, only 6 minutes left. So I'm on time. So okay, now questions. This is regarding you suggested about serving multiple endpoints in a single AWS Lambda function. Wouldn't this cause cold starts due to fatter deployable and also maintenance issues, side effects? Secondly, what do you view on best practice for testing Lambdas? For example, use mostly local testing or excellent questions. First, multiple endpoints doesn't matter. This was my observation because Quarkus optimizes a lot. You can have 50 endpoints. It really doesn't matter. The size of the zip really doesn't matter. What matters is if you have lots of external dependencies and reflection would matter or stuff like that. But Quarkus optimizes already, so it is fast enough. Doesn't matter. And we always use the proxy integration, so we can have as many endpoints as we like. And by the way, someone asked me about the performance. So we have 50 milliseconds invocation time with an application which looks like 20 years, not exaggeration, 10 years old Java EE application, right? So no code start, fatter deployables, also no effect. Side effects maybe the only downside is, the more endpoints you have, the more merge conflicts in Git you can get. But this is like a microservice discussion. It's nothing to do with Lambda. Then testing. Okay, I don't like the okay, testing is great because we have the best possible testing experience. With this particular Lambda, what I can do, I can say Maven compile Quarkus dev, and my Lambda will run locally with Quarkus. It started. So this is my Lambda. I can run it. I can test it locally. I can do whatever I like. I can run integration tests. And of course, it will call S3 to Amazon, what I will suggest, because you can create as many S3 buckets as you like. So I don't like local stacks, because in the past, it was always troublesome. And the more complex cloud environment gets, the harder it is to replicate it on your machine. And my experience is, what's cost really time is thinking about the IAM securities, IAM roles, the security groups, a big one, integration with then JSON web tokens. So this is where I spend most of my time. Not writing Java code is relatively simple. So I like to test it as soon as possible in the real cloud. And usually what happens, I push to a code commit or GitHub or whatever, and every push initiates code pipeline which deploys Lambda. This is what happens behind the scenes. I hope I pronounce your name right, Guo Liang. I hope you are happy with the answer. Next one.
I think
Marcus, you have a question.
Sorry. Guys, we have just left a couple of minutes. This will be your last call for the questions. I think we have got...
Exactly. I have 5 minutes to go. So usually I'm overtime. This time I'm undisciplined, but you're not efficient. So no, I can walk through the code, ask specific questions, but this is real-time performance. And S3 is fairly slow if you compare it to DynamoDB, for instance. With DynamoDB, it will be even faster. And with this call, we can go. We can actually, if there are no questions, we can go AWS Lambda pricing, and Harpreet, you watch the chat, and if you see that there is a question, interrupt me.
Sure.
And there's a pricing calculator, yeah, exactly. And what I would like to do is node free tier, and we go to Frankfurt, and then we can try Singapore even. And ARM, this is what I usually, this was a mistake. Two requests per second. Duration were, let's say, 60 milliseconds. They were 55 or 60. And I had 2 gigs of RAM. And show calculations, this would cost me $9 a month. This configuration with two requests per second the entire month. And I'm talking here about an entire Java microservice. And there will be no cold start, obviously, by two requests per millisecond. And this is really, usually I would, on average, I would count an average enterprise application, maybe, because there are nights and weekends, so maybe 1. And this is, of course, $5. And now we are talking. Now is cost-driven development, because at the end of the month, you see on the bill exactly my charges resource cost me $5, and management asked me, why so often, Zaga? Because lots of vehicles were charged, and you are earning per charge €1, you're paying, I don't know, 2 cents, so it's okay.
Adam, just one caveat here could be the spiky workloads. For example, you can have like lots of this kind of loads for lots of different durations, but let's say on the idle days, you would have like maybe 1 request per second, or something like that. So that could, by
spiky, you get the cold start with every spike. How it works is the Lambda is like the hot is 1 Lambda, but if it's busy, the next one could be a cold start again, but then it's warm again, and it stays in the, actually it's exactly the same principle as EGPs were a few years ago, exactly the same. But you can have provision concurrency, and it's still going to be cheaper than anything else. And now it comes, what you can do, you saw the Quarkus, you could run exactly the same application on Fargate as well.
Yep.
So you can have even one load balancer which switches between Fargate and Lambda, and you can even use Lambdas for Spark. So this is actually what I like about it is my old code, my old simple code, and I can decide now to run it on EC2, which is not serverless at all, ECS Fargate, which is serverless but more traditional serverless, or Lambda, which scales well, sorry. And to my client, they have no problem to buy provision concurrency. And what provision concurrency is, you can keep some Lambdas warm, you pay more, but if they pay $10 a month, and the Lambda is larger, what you saw, they are paying $10 per month per application, basically, in Java. So if you deploy Kubernetes to the cloud, EKS, for instance, you are paying roughly 100 euros just for the control plane. There are not even worker nodes involved, just for the control plane. Sorry, Marcus asked a very good question. Which part of the state of Lambda is automatically managed by AWS, and how do they persist the state internally? Everything is managed by AWS, or which part of the state of Lambda? State. The JVM is frozen with the entire state of the Java, and then loaded to memory again. So this is like, almost like a snapshot. This is my understanding. And what we have as state as well, we can use MicroStream for cache large amount of data in temp folder. This would work. So what we could do, this is completely different use case. We can load pro Lambda everything to temp folder and then use MicroStream to deserialize large object graphs for machine learning, for instance, but the temp folder is not shared across Lambdas. Another use case, Lambdas support EFS, Elastic File System. So what you can have multiple Lambdas which share state like EFS. EFS is like NFS. So you can have, shared state in a folder. It's also used. But what I wanted to show you, like the bridge, we are writing MicroStream vehicles and to S3. S3 distributes events. Other Lambdas are listening to the event and can do something analytics or whatever. So this is like, a cloud native application with managed only services, right? And Marcus also asked question, what is the min resource for Lambda? 1 CPU, 2 GB of RAM? No, I actually can run the example with 128 megs, maybe be rough with S3, without 128 megs. Quarkus works well, but this is the minimum, and this is 1/13 of a CPU. Usually this configuration would run happily with 256 megs of RAM, but wouldn't be the most cost effective because it will execute slower and you will pay more. Therefore, a 2 gigs of RAM is a good trade-off, I would say. More than that, usually not. Less than that, maybe it is got a little bit cheaper, but slower. But who cares about $9 a month? Yeah, 128 megs of RAM. There, you cannot ship a Lambda with less than 128 megs of RAM. This is the and Java runs fine with 256 megs of RAM. Yeah, perfect. Any other questions? Come on. So what's wrong with the meetups? We have 3 meetups and no questions. So maybe I forgot a question. Yeah, and this is what I do in most of my projects with Lambda. If we go to the cloud, then I would really go to the cloud and use the cloud services, or I would stay on my OpenShift cluster at home. Also works. But trying to replicate your home environment in the cloud, and what will cause cost explosion, and you will have to administer everything anyway. Very good. Stephen asked me, my quick research on MicroStream is that it is a physical memory graph, but you are discussing in more terms of serialization. Yes, this is also discussion with Marcus. I'm using the first step. So this is maybe not that known. You can use a MicroStream as a safe serializer. So what I like about that, actually, the killer use case here is the following. I get the JSON objects anyway, because this is the, Stephen, where are you from? This is I'm just interested. So you see, I get the charge object from the outside, and the charge object has vehicles, and it is like a JSON object from outside. I get it. So, and I could actually change the object, add object graphs, and then say MicroStream serialize it. And I don't care what's inside. And MicroStream is a safe and fast serializer, and it will serialize it for me. So I could use the persistence. Actually, enterprise edition of MicroStream has an S3 option. So I could use MicroStream as a database. In this particular case, I only use the serializer. Australian in Singapore. Nice. I hope I clarify this. So think about this, what we wanted to have in Java for years is like object-oriented databases. This is also what I did lots of evaluations in 2000s. Now we have it. You get all the objects, you can serialize it, you can store it to S3, send the pointer over the wire, SQS or SNS, and on the other side, deserialize it from S3. So it's more like, don't make me think storage. Yeah, and Marcus also answered what Marcus said is MicroStream serializes the core of the MicroStream persistence layer. You can use the serializer standalone. MicroStream serializer is also highly secure serializer that was written from scratch to eliminate deserialization attacks. And what Marcus told me, there was like a count of a review by a researcher who said it's safe, right? Marcus, this is what maybe you put it in the chat. So it's interesting discussion.
Yes. So if you want to build a Java application and not become hacked, then you should have a look on MicroStream serialization. So because it's was written from scratch and works fundamentally different to Java serialization, which is very insecure. And Mark Reynolds said it's the half of all vulnerabilities in Java are linked to Java serialization, and so this is the biggest security issue of Java ever. And so we do it fundamentally different. So if you don't want to be hacked, check out MicroStream and for high secure data transfer.
And another thing is with standard Java serialization, this is what even if I would put, I could use externalizable, for instance. So then I will be able to serialize the stuff without serializable interface. The problem is with Java serialization is really brittle. So if the object changes slightly, I cannot read it anymore. And with MicroStream, I could survive longer. So I don't have, I don't have to use the long-term persistence. But also I had a chat with Marcus. So okay, in larger enterprise projects, I would like, to buy long-term support, because if I save something with MicroStream to S3, 5 years later, I would like to deserialize it, and there should be a long-term support and say, yes, okay, this is our enterprise support policy. And or what would be a great feature, I think, is the ability to read, from S3 like a converter and write to a CSV, because then there could be another S3 bucket, and there's Amazon Athena or S3 Select, where I can actually perform, calculations on S3. So also a huge enabler. Yeah, and MicroStream is open source. Yeah. Any other questions? So what's wrong with you? So we even criticize a little bit, JavaScript, and no one gets mad. So it is unusual. So Harpreet, I told you after the talk there will be Java #1, and
yeah.
all Python and JavaScript occurrences is going to be deleted. In the cloud.
So
Always
as a Java
in the cloud.
So just a quick question on the for the sake of comparison, right? So there is this framework called Apache Ignite, right, which has a similar in Fabric. It's they call it like in memory where you could persist objects temporarily, like some very heavy objects which are used for very heavy calculations, and then you can resume back and take it from there. So would you say that MicroStream is something similar, but on the cloud side on the things?
Marcus?
I would say no. It's completely different. So what I know about Ignite, it's in-memory data grid.
Yep.
And in-memory data platform. And MicroStream actually is a Java library that allows you to store your object graph. So we really store a native object graph. Java native means as it is in a memory. So we serialize and restore it in the memory as it is, and you can not only store the entire object graph, you can also store single subgraphs, and you can load and restore also single subgraphs. So this allows you to, a completely object-oriented programming model instead of using any different database specific data structure, so you don't have to, there are no more mappings, so you don't have to deal with key value stores or any other object relational mapping. So yeah, use your classes as they are. There are no dependencies, there are no specific interfaces to implement or superclasses or annotations. So you can use just pochos and build any object graph of any size, of any complexity. You can use circular references, inheritance, everything that's possible in Java. Build your object model and then simply store it with only one store method. So it's super easy to use. And then with lazy loading, you can load only parts of your object graph in the memory, and you can use lazy loading to load subgraphs on demand. So this is completely different to any other storage technology on the market, which are mostly in-memory data grids or database systems. So MicroStream is not a database system. It's not a distributed cache like Redis. It's not an in-memory data grid. It's actually a persistence layer to store your Java native object graph as it is and to restore it in the memory. That's it. So because we believe that Java provides everything you need for high performance in-memory computing. So we have Java Streams API to search object graph in microseconds. So this is absolutely incredible. You can keep the object graph in memory and search it in microseconds. This is super fast, up to 1,000 times faster than a JPA query can be. And the only thing missing in Java is how can I store my objects highly efficient. And this is actually what MicroStream does. So this is the last missing piece of puzzle to store and restore your object graph.
Got it. Thanks. All right. So I think we are already above 10-15 minutes. So just respecting audience's time. So I don't see any more questions. And yeah, so any few more last words to say, Adam, before we close? Oh, we have another question. Please,
yeah, absolutely. So if you can play, I think the entire month, and it will cost nothing. So for AWS with what costs a little bit more, but this is not Lambda. If you have NAT gateways or something, but this is irrelevant. So just if you pick Lambdas, you can play with the free tier. Absolutely. Stephen, thank you for the questions. Everyone for the questions. Great questions.